Glad to see you were able to find this video. I'd also be glad to hear from you. Let me know what you want to see or what you're having trouble with so that I can make content that's useful and meaningful to you. With that said, let's jump right in, shall we? Our previous video was the lecture portion of this module when we're talking about objects in space. And the reason we're doing this one first is because I want to make sure that we have a fundamental understanding of what the different things in space are so we can have conversations about how they interact and how we organize them moving forward. So this video is to take up the practice questions at the end of the lecture video. Just a high-level review, what we're looking to do is identify the different objects in space. And then some of the objects are similar to each other. I'm looking at the space junk category that I classify them as. So we're looking at comets, asteroids, meteors, meteorites, meteoroids. And we're also going to just make sure we feel comfortable with what they are. So the first one we're talking about is what object is known for its tail? The answer is comets, and the reason comets are known for their tail is because as they move closer to the sun, the frozen gases melt, and so they're able to let particles and debris escape from the tail, so that way we can see that beautiful tail as they travel past. Where would you find the largest cluster of asteroids? This is in our solar system. I didn't specify that, but in our solar system, where would you find the largest cluster of asteroids? And that's called the asteroid belt. The asteroid belt is between Mars and Jupiter, which Mars and Jupiter are the 4th and 5th planets in our solar system. And there are over 1 million asteroids in the asteroid belt. So there are a lot of asteroids in there. What are asteroids made of? So asteroids are made of mineral rock. They're usually made of iron or nickel, and they're hard rock or stone. So there's not really got the ice and gas that you would have in a comet. What are comets made of? So just like I had mentioned, they have frozen gas and small dust particles along with rock. And that's what gives it the tail, right? So as they come closer to the sun, the ice melts and we're able to allow all of the debris to fall off. So they are similar in composition to asteroids. The big difference here is that they have the gas that's frozen. What are meteoroids made of? Okay, so meteoroids, if we can remember from the lecture portion, are very similar to asteroids. The real big difference between a meteoroid and an asteroid is that a meteoroid will be under 1 meter in size, versus the asteroid can be much, much larger. So the composition is similar, so it's going to be iron and nickel. And sometimes it will have the ice in it, but generally speaking, it's usually made out of the mineral rocks. What is the primary factor which classifies meteoroids as a meteoroid? So here, what makes a meteor a meteoroid rather than an asteroid? Because the composition is so similar, what makes it a meteor rather than an asteroid? And that has to do with the size, right? So if it's less than 1 meter in size, it's going to be considered a meteoroid. If it is larger than that, it's going to be an asteroid. What differentiates meteorites from other objects in space? So this is meteorites. So meteorites have passed through the Earth's atmosphere and has made it to the planet. So we have comets, we have meteors, and we have comets, meteoroids, and asteroids. Got to get them right. Those are the 3 that exist in space. Once any one of those have made it to the Earth's surface, that makes it a meteorite. Which object is made of plasma and gases held together by its own gravity? So this is stars, and there are tons of different stars, and it has to do with the different types of gas that is used in the composition of it, and so that will change the color, and as well as how much stuff is in it will change how big it is, and how big it is will determine how long it can stay alive, because it's all made out of gases and it's on fire, essentially is what it is. And so as all of the gases burn out, the star will eventually die. So there is that life cycle of stars, which is actually very fascinating. I could probably do a whole separate piece on that, from when it becomes born to as it ages to when it dies. So there's a whole arc there that can be really interesting, and if you're interested, I would suggest looking it up. It's very fascinating. What is another word to describe a moon? So another word for a moon is a natural satellites. And satellites in general are objects that have an orbit in space, so they're traveling around something. Natural satellites, like I said, are already existing in outer space. We didn't put them there, so there are some satellites that humans have put in there, like our global positioning systems and remote satellites. There's lots of different organizations that have been studying space, and we've been putting stuff up there to track stuff. But the moon is one of those ones that we as humanity have not put in there. It was already there, and it's orbiting around planets generally. What is a shooting star? So a meteor is a shooting star, and the meteor versus the meteoroid and the asteroid and the comet is the one that is actually working its way through the atmosphere. So any one of those space junks that have started to travel through the atmosphere then becomes a meteor. So the composition can change based on what it originally was. But the reason it's considered a shooting star is because as one of the space junks move through the atmosphere, there's enough friction that the actual junk, the piece of rock that is coming through the atmosphere, it's starting to crumble away. And so it's going to have friction on it, which actually kind of makes it burn, right? So it's going to burn some of the stuff away, and it's going to rip apart with the different pressure that's being pushed on it as the atmosphere is pushing against it and the rock is pushing into it. Lots of stuff going on, and it's just going to start breaking stuff up, and that's going to cause it to leave its tail behind. So it's similar to a comet, but the reason we actually see shooting stars is because it's close enough to our atmosphere that we can actually see it, versus comets are something you need to see with a telescope. So what is our sun? Our sun is a star, and it's the sun of our solar system. It's what's keeping us alive, and we'll look at that in more detail when we start talking about our solar system. What galaxy do we live in? We live in the Milky Way, and it's technically a spiral galaxy, so it's kind of like a pinwheel. It's going to have all the different arms associated to it with a center point. What is the difference between a planet and a moon? So this has to do with the orbits. So if we remember the lecture portion, the moon travels around the planet, and the planet travels around the sun. So technically the moon is also traveling around the sun, but it's actually caught in the gravitational pull of the planet, and the planet is pulling the moon with itself all the way around the sun, right? So moon goes around planet, planet goes around sun. That's the way to remember it. What object gravity is so powerful that it pulls even light into its core? This is black holes. And so technically you can't actually see the black hole because the black hole is sucking in light, and the way that humans see is we see the light being reflected off of objects, and it comes back to our eyes and we can then see it. So we're not actually seeing the thing, we're seeing the light that's bounced off of it. That's why black holes are black, because there's the absence of light. It sucks everything into it, and so it's just a black hole that we can see. And black holes usually are formed from the collapsing of a sun. So, or not a sun, a star rather. I mean, a sun is a star, but it's the collapsing of a star. It's such an explosive, and there's so much energy there that a black hole can be generated, and it will continue to expand as it keeps sucking in more and more stuff. Black holes also very neat. What is a large cluster of objects held together by gravitational attraction? This is a galaxy, right? It's got a whole bunch of different things, and it's being pulled together. So in our galaxy, we're going to have different planets. We're going to have our sun. We're going to have different comets and asteroids and meteors, all kinds of stuff that are all pulled together. And our galaxy is called the Milky Way. How do asteroids differ in composition than comets? So comets has the frozen gas, right? So comets are the ones that have the temperature, they're created at far enough away from the sun that they'll have cold, so that they're able to actually lock in some of the dust particles as well as some of the frozen gases. So as it comes closer to the sun, it's going to melt, causing the tail, versus an asteroid is usually closer to the sun, and so it won't have the cold temperatures needed to freeze the ice in it. And since it's not cold enough to have the ice there, there's nothing to trap, there's no debris that falls off. It's already at the point of being empty of all of its gases. So that's really the key point here, is that comets are created far enough away that they're able to have lower temperatures where they are so that they can have their frozen gases. What gives a meteor the appearance of a falling star? So this has to do with the combustion and the friction that is going on from moving through our atmosphere. So as the space junk, the meteoroid, the comet, or the asteroid pushes through our atmosphere, there's enough friction on it that actually causes it to combust. And that, along with the debris that's falling off, so whether it's the dust or if it's larger chunks of the meteor, it all comes off and it leaves that residue behind it as it continues to move through. What is a meteorite made out of? Okay, so if we can remember what a meteorite is any kind of space junk that has hit the Earth's surface. So it's actually made it to Earth's surface. So that means it was originally a meteor. It was coming through the atmosphere at some point before it got to the Earth's core. Not the Earth's core, the Earth's surface. It would be very impressive if it made it all the way to the Earth's core. So in that case, it would have been either a comet, a meteoroid, or an asteroid, right? Because then it would have traveled through and became a meteor, and then it would have been made into a meteorite. So using that logic, we can say that it's got the same composition as your meteoroid, your asteroids, and your comets. The likelihood of having the dust and the gas and the frozen ice still there is very slim, right? Because it would have lost it as it got closer to the sun, and then as it started to make its way through the atmosphere, more and more of the gas would escape. So the gas percentage would be probably really low, versus it would be mostly stone and rocks and dust is really all that would be left by the time it actually made it to the Earth's surface. But originally it could have been a comet, and so it could have originally had frozen ice with it, or frozen gas. What is a meteor made out of? Okay, so if we continue back what we were just talking about, a meteorite would have first had to have been a meteor, and a meteor would have originally been made out of a comet, an asteroid, or a meteoroid. So a meteor is probably going to have the stone, the rock, the dust, and maybe some frozen gas, because if it was originally a comet, it might still have had some of the frozen gas, and as it's making its way through the atmosphere, it may still have some of that frozen gas that is melting as it goes through because of the combustion of the pressure and friction on the actual chunk of rock that is coming through the atmosphere. So you're going to be losing the gas. The amount of gas that would be there is probably limited. It's mostly going to be your stone and rocks. What objects rotate around a star? So if we go back to what we were talking about, planets and moons. So moons go around the planet. Planet goes around the star. I mean, technically everything goes around the star. If you look at a map or a diagram of the solar system, everything is rotating around the sun. But really what I'm trying to get at with this question specifically is the difference between a planet and a moon. If we can all remember Pluto, I'm not showing my age too much. Pluto was a planet. Pluto is not a planet. The reason Pluto is not a planet is because Pluto actually rotates around Neptune. So if it's rotating around a planet, it's probably a moon. And so then the moon goes around the planet goes around the sun. And that's really what I'm trying to get at here, is what is rotating against what. Yes, technically the moon is also going around the sun, so technically everything is going around the sun, but what I'm really trying to get at is that the moon goes around the sun, the planet goes around the sun. So after all of this, we've answered 20 different questions about the objects in space, and I could have gone with a whole bunch more. The idea is here to try to remember what the different objects are, try to remember their names, and try to remember the key differentiating factors between them. So again, if I go back to the rotation, the moon goes around the planet, planet goes around the sun. And then if we go back to the space junk category, comets have ice, asteroids are huge, meteoroids are smaller than asteroids. They're only at 1 meter or smaller. Meteors are the ones that are coming through the atmosphere. Meteorites are the ones that hit the planet. If you can remember those things, you're going to do pretty well, at least for this video series. From what we're talking about, it'll give you a good understanding of what we're talking about. But that's kind of the hard and fast rules that you should probably try to remember. Our next video, we're going to talk about the different objects in our solar system specifically. You know I love to hear from you, so if you have any questions or any future topic ideas, please let me know. Reach out to me in whatever channel suits you best, and I look forward to seeing you at the next video.